Yeah, hi, good morning, everyone. My name is Randy Brailsford. I'm part of the Visio and SharePoint and product teams here in Seattle, Washington, and would also like to thank everyone for taking the time to join us this morning. I just wanted to take a minute or so to introduce our team. So our focus is really to help our federal customers better understand how the increased capabilities of Microsoft solutions that many of you may already own or have access to and can help meet new mandates for accountability and transparency. And so for any of you who aren't already familiar with who ProModel is, they're one of our leading gold partners. They were our Data Visualization Partner of the Year in 2009 and Partner of the Year finalist again last year. And so with the Microsoft Data Visualization Solution and their simulation-based decision support tools, ProModel's already helped many of our clients visualize, analyze, and optimize their processes and see a quick return on investment. So you'll see my name there on the first slide, and we've got our contact information included at the end of the presentation if you'd like to get a hold of myself or Scott Bradley, my counterpart here. And so with that, Steve, I'll turn the presentation back over to you and let you introduce the rest of the team.
Okay, thank you very much, Randy. So also on the ProModel team here today is Dave Tucker. Dave's a Master Black Belt. He joined ProModel last year, and before that, though, he spent quite a bit of time as a great customer of ours at the United Space Alliance, involved in being in charge of Lean Six Sigma initiatives and utilizing simulation as well as other technologies. So Dave is going to be joining us and sharing the benefits of his experience. And Kevin Field is the ProModel Product Manager for Process Simulator, and Kevin will be getting into showing us how the two tools work together. So I thank those guys for being on with us today, too. Very much appreciate that. So with that, let's go ahead and kind of get started. So the brief agenda here. So who is ProModel? Just real briefly. Talk a little bit about the business process challenges that you guys have told us you're facing and that we understand from working with you, and that Randy and Scott hear from you guys as well. Look a little bit at when is simulation appropriate. Then get into the tools a little bit and show you how they work together. Process Simulator 2010, Visio 2010. Then look at bringing a flow diagram, a Visio diagram to life with Process Simulator, how that works. And then kind of wrap up with just some high-level highlights of some case studies, and then the Q&A at the end. So that's what we'll do today. So real brief, who's ProModel? Randy did a nice job of introducing us, but we provide simulation-based or predictive analytics software and services, typically in the business intelligence, the BI, or the business process analysis, or the business process optimization space. That's really our strong suit. And we feel like the tools and services help companies empower them to visualize, analyze, and optimize your future operations so that you can make better, faster decisions today. And we do that through a combination of more than 20 years of experience in delivering predictive solutions to the military, to the government, and to the rest of industry with our own in-house developed technology. And in this case today, we'll be looking at one of those, Process Simulator with Visio. So some of the challenges that you guys have indicated you face and that we understand from working and talking with many folks every day, probably the biggest one we saw, we keep hearing about, is you need to do more with less. There are a lot of time, financial and resource constraints these days. How do you deal with that? Understanding and quantifying risks in your processes, determining the actual root cause of issues, and then trying to identify and test potential improvements without interrupting your live systems. Projecting resource requirements over time, realistic ones. Staffing and personnel utilization and allocation, that got a lot of input as a big issue these days. Just communicating information across an organization, across an enterprise. And, even to the point of just understanding there's so much data available today and lots of tables and text, and how do you visualize that? How do you put it in a form that is meaningful and can be communicated? So at this point, I'd like to turn it over to Dave for a little while, Dave Tucker, and share a little bit about some experience that he's had at United Space Alliance.
Thanks, Steve. It was my privilege to work in aerospace over 20 years on the Space Shuttle program, and for the last 10 years, I was using Visio, Process Simulator, and ProModel as part of our Lean Six Sigma efforts. So briefly, I want to just discuss some of the process characteristics that would often lead us to using simulation tools. First off, if it's a high visibility process, it might be a good candidate for simulation. We had a supply chain problem dealing with thruster motors for the space shuttle. It was taking a very long time at the repair facility to get them returned for flight, and this actually threatened to delay shuttle flights. So it was a program level issue, a lot of visibility. From using the model, we were able to show some credible data that predicted shortages. And then actions were taken after making the model results known. Another process characteristic is anything that's repetitive with many steps. The tile production process for the shuttle has over 300 steps. It was a great candidate for simulation. We modeled that and discovered a lot of ways to improve that process as well. If something has high volume quantities, it may be a good candidate for simulation. We had a situation where we had to scan over 20 million documents in a short amount of time in order to comply with some NASA rules. We didn't know how many people or equipment we needed, so we observed some scanning operations and built a model, which helped us to predict not only what resources we needed, but also how long it would take. And we used that simulation model and the results, and basically it ultimately saved us $250,000. More importantly, we met the NASA deadline. Another process characteristic is something with a long cycle time, and this is another example I want to cite. We were building some prototype gun barrel parts for some DoD business, and we were asked to manufacture a large amount. Well, we didn't know if it would take us 6 years or 6 months. So we built a simulation model, and we used that to optimize our use of all of the process equipment and people. And that helped us to reduce the cycle time from about 14 months to less than 6 months. So again, long cycle times, good candidates for simulation projects. If a process impacts many resources or has critical deadlines, again, those are all situations where you should really consider using simulation tools. The last characteristic I'll mention here is just anything tied to a Lean Six Sigma project. In my experience, we began using simulation tools as a part of our Lean Six Sigma effort. So we would look at black belt and sometimes green belt projects as possible candidates for modeling. We had a number of good simulation projects, especially a lot of paper processes, like requisition approvals or engineering changes. And so it was a great tool to use for our Lean Six projects. Let me just kind of wrap up this portion by saying that for all the simulation projects I've listed here, we used Microsoft Visio to create process flow charts, process maps, or value stream maps, sometimes even room or building layouts. And we also used Process Simulator, and in some cases, ProModel. And all the projects were very successful. Steve?
Dave, thank you very much. We really appreciate that. So a little bit of a visual, again, just to build on what Dave had said. Simulation is a great tool because there's no impact on your operations. There's no risk in using it. And so, the ideal is to, the more risky something is, the more costly, the more impact on your operations, the more it makes sense to do some simulation first. I don't think anybody wants to get in a plane where the pilot is trialing and erroring their first couple times flying. You'd much rather have them had done a bunch of simulation before they got to pilot the plane. So that's sort of the right type of application. Another little bit of visual here is we talked about risk already a couple times, and a lot of traditional analyses get done with averages. We like to use average numbers. They're fairly easy to get at, but that can actually get you in trouble if you rely on them, and it can be quite painful, as our diver is going to find out here in a bit if he winds up landing on a spot that isn't the average of 10 feet in that pond. So just things to keep in mind: when to use simulation, and when not to. So let's do a quick little example of a real another real case study. Just some highlights. Evans Army Community Hospital in Fort Carson, Colorado. They have Visio and Process Simulator, and they were having some issues with their behavioral health patients. Their walk-in patients were experiencing a really long wait time, over 120 minutes before they were being seen, and so consequently many of them were leaving without being seen at all because of the wait time. They also were having the medical evaluation board timeline for making decisions was 18 weeks, which was much longer than they wanted, and they were space constrained, so they couldn't just say, well, let's just add a bunch of providers and take care of it. It was not that simple. So, they needed a way to kind of look at their system and determine, what were possible actions and what would the results be. So they visualized their system. They built both a current and future state map of their situation, a value stream map. And let me just and the model was built in 3 days. And so I think at this point, Kevin's going to kind of run this thing a little bit and just talk to it briefly.
Yeah, I just want to show a quick animation of the process in question here, just showing some of the things that you can see, how visual this really is, showing the patients flowing through the system. I might be going a little faster. I'm not sure how the animation's coming through, but one of the other things that you can see is that some of these resources, the doctors and nurses are turning different colors. Green meaning they're in use, and red meaning they're unavailable at the time. So you can get some of that visual. You can also see some numbers coming up here, around the process shapes. And what it does is, and here they're all down. Maybe I can quickly get it onto the next thing. What it does, it kind of shows you how many patients are, kind of in process and in building up. And from a manufacturing standpoint, you might say work in process, right? Here's patients in process. Some of the other things you can see are, as the patients exit, you get some statistics here on the screen telling you the total number of exits, how long they were in the system on average, and give you some good representation of what's happening.
Thank you, Kevin. Appreciate that very much. So they built their model, and from there, obviously, you need to do something with it. Building the model isn't the point; it's getting results and getting answers. So, in the analysis phase, what they were interested in doing was looking at sensitivity in the system. So, you want to make sure you're working on the right, situations. So, they used the model to help identify, where the bottlenecks and where the issues were, and then take a look at, as people suggest changes, what are the impact of those changes. So in this case, I know this isn't the best legibly here, but what they were looking at, these are some data inputs that were used for the model, not all of them, but just some, and they were looking at their providers or their resources, so the psychiatrists, the psychologists. They were able to input from their actual data that they took, the utilization, their current utilization, how they break down between the types of patients they were seeing. They had data on their, how many patients walked in per day, the number of appointments per hour. They were able to develop some distributions, some statistical distributions to help, the accuracy of the model. So a lot of data that they had. Many healthcare facilities and a lot of facilities have a lot of data, but what do you do with it? So they were able to get that into their model, and from there, they could run, and they developed altogether 10 scenarios. Here, this chart is an output chart that they developed with just 5 scenarios. Again, I know you can't see it all that well, but the idea is there's 5 different colors here down in the legend, and it's different suggestions that people had as to what to do to help with their metrics. And this chart happens to be an average patient cycle time chart, and it's from the time, if they stayed through the waiting room, this happens to be the time, the actual treatment time. So just to look real briefly at one scenario, we'll look at the light green scenario in the front here. So, and that actually turned out to be the one that they chose of the 10 they tested. you basically can see that the left-hand side is the percentage of patients who had this experience. So, for example, 30% of the time, if I move over to my green line here, the cycle time was about 115 minutes. So on average, for this scenario, which was 2 additional patients that they were hoping to be able to see per hour and 3 additional resources or 3 providers, their average cycle time is about 118 minutes. So this is just one of the many things they sort of looked at to help determine what changes to make. So the last stage is sort of to optimize. Once you get some ideas and you start throwing them out onto the model and running them, they actually came up with 10 altogether. And let's blow this up a little bit here. And the one we were actually looking at that other the chart just before was their scenario number 7, where they added 3 resources, and it brought the cycle time down to 110 minutes. And we'll show you really the benefits here in just a minute of this scenario. But what they were able to come up with was the resources were put together in the form of a triage unit. So it wasn't so much adding a lot of providers because we said earlier they're space constrained, but they were able to figure out that if they took a psychiatrist and a nurse and a 3rd resource and grouped them together as a triage unit, they were able to make some very impressive changes to their system, and which are as follows here. Take a look at some of the results that they actually got. So the new triage team enabled the treatment of 2 more patients per hour. Their patient wait time now is down under 30 minutes from the more than 2 hours that they had at the beginning before they did the study. Relatively, nobody was leaving anymore without being seen with a wait time that low. It was not bad at all. Reduced the patient cycle time by 8 minutes an hour. That was in the prior chart. Again, you probably couldn't see it, but it reduced it from 118 to 110. So they got that down as well. The MEB decision time, which they were concerned about, the Medical Evaluation Board, they dropped that by 4 weeks. And they actually won an award from the TRICARE organization for this project. So that's just one example of what one of our customers did with Visio and Process Simulator. So kind of wrap up this front section here a little bit before Kevin gets into the how the tools work a little bit. Just some the advantages really that simulation and the Visio technology can bring to really any process improvement. It doesn't have to be a Lean Six Sigma, but any initiative is, first of all, you're getting more realistic analyses because you're able to account for the variation and the interdependencies of a real-life system. You're going to be able to work on the right problems. You're able to do sensitivity analysis, so you're identifying where your issues really are, because if you could spend a lot of time fixing things that aren't necessarily going to improve your throughput of your whole system, this helps you pick those right issues out. Low risk, we talked about this a couple times already. Very low risk environment lets you test many, many solutions, more than you could if you were, trying things out for real with your real life systems, because we've got rapid visualization and the scenario analysis capabilities. So we kind of like to refer to it as virtual Kaizen. For those of you who are Lean practitioners, a Kaizen event, you're typically, really going out to your system and your floor or your ED or whatever, and you're actually doing experiments. This will help you do a lot more experiments in a virtual world, which has a lot of advantage to it as well. Looks really at helping you with resource effectiveness and utilization, improving that. For the example we just looked at, that was able to help determine, what types of resources, how many, when, and where. So, quite often you can maybe tell through more traditional analysis, this is an issue, but this helps you precisely determine, with resources where and exactly what you have to do. So you're a little bit more effective with your implementations. And then communicate and collaborate much more easily and objectively. It really takes the kind of the emotion out of decision making. And again, just the whole idea really is to help you guys all make better decisions for your organization. So at this point, turn it over to Kevin again and get into the technology a little bit.
All right. Thanks, Steve. Well, Process Simulator, as you know, is an add-in to Visio, and it does work with all three versions of Visio, the standard, professional, and premium. Of course, there's a lot of capabilities that Visio has, and Process Simulator, takes advantage of those and utilizes those. But in particular, the ones that we want to kind of focus on a little bit here today are with Visio Professional. You can create dynamic, data-driven diagrams, and that's part of the data graphics capability and external data linking that you can do. Now, Process Simulator extends, the ability to link up to historic and even current data that you may have for that diagram to allow you to show some future and predictive data that the simulation results show. And I'll show you how that does that a little bit later here. You are also able to publish diagrams to SharePoint. It's a capability that Visio has. And what that does is with your project team, your simulation team, that means that you're going to be able to have a central repository where you can share those diagrams and models and be able to have version control of checking things in and out. It's a nice capability. Then taking it up a notch here to Premium, the Visio 2010 Premium, one of the new capabilities is this concept of sub-processes. And I'll, again, also show this, but it allows you to take complex, highly detailed, a lot of process steps you may have at one level and be able to break them down into more manageable views or into a sub-process, or what we say in simulation, into a sub-model. Now, that's something that we can do today with the Visio Premium. Another capability with the Premium is what you have with Visio SharePoint Services, and you're able to create some dashboards. Now, currently we don't have this capability, but we're looking at doing it where you can publish your diagrams up into SharePoint, your Visio diagrams. But what we'd like to do, and where some of our vision is that you'll be able to then publish those with your diagrams with data graphics, and you can also then be able to run scenarios and view the results up there. Maybe have a manager do that, or some other people that may not want to get down into the details, and they'll have that capability. So that's a future thing that we're looking at implementing and taking advantage of capability in the Visio. All right. What I'd like to do now is get into kind of the live demo here. I'm going to switch over to my desktop. One of the things that you'll see is that this is Visio 2010, for those who are not familiar with it. It has the Fluent UI and ribbon interface, and what we do, like I said, Process Simulator is an add-in. And so we come in as an add-in and we add a tab to this ribbon. As you can see, we've got a lot of different elements here for Process Simulator to be able to create a diagram. And so what you do is you basically can take your diagram, or if you're creating a diagram here, and start to build a process. Right? Very simply, easily be able to do that. Visio 2010 has some great capability there. And right away, you can begin to have your diagram here. Now, Process Simulator then, will use all the shapes. We have a stencil that we've set up, but it's basically just your Visio shapes here. And what we do then is we extend the properties on these shapes. So as you have a diagram, you can right-click on it and go to a menu item that we call Properties. And within here, we have some simulation properties like cycle times, resource requirement that may be a resource that may be required here at the activity. You can get into defining how available that activity is, what percentage of the time it's available. You can add a calendar to it. You can do some more detailed logic. You set capacities of the activity, some constraints that go on there. You can define move times, the amount of time it takes between the process steps if there's a physical aspect to it. You define entities, and the entities are the things that flow through the system. So in the case of the hospital, we saw obviously entities were patients, but it can also be parts and documents and things like that. So very quickly you can set up a model, change some of the properties, set cycle times, things like that, and you can be off and running on your simulation. We put some general default like times and things like that in there, but immediately you can start to run it. And I'll show you here just how quickly. I'll just hit the big play button, which is very difficult to see, and you can see that immediately you can start to get some animation and some things there. I'm not going to go into the statistics yet. Okay, another thing then is if you've already got pre-existing diagrams, what you can do is you can open it up in Visio. With Process Simulator installed, you can come over here and you can click Convert the Diagram to a Simulation Model. And what it does is it goes through and adds all the default properties that I showed there, the simulation properties, to all the shapes and connections in your diagram, and you can immediately hit play and run a simulation. Now, it may not have much value until you actually go in and change some of those times, but immediately you can take existing diagrams and begin a simulation project right away. Now, I mentioned with Visio Premium that you could take advantage of the sub-process capability. Now, what that does is, for example, this is a smaller diagram, but just imagine one of your diagrams where it could have, hundreds, maybe 1,000 steps in the process, and you want to reduce or simplify that. Well, Visio has capability, like I said, of sub-process, where you can take this and create a sub-process from a selection of shapes. So let's say I'm going to take this whole process here, or these steps, and I want to include those in a sub-process. So all I have to do is highlight them, come up here to create from selection, and when I select it, it's going to take all those and immediately put it on another page. Now, what I'm going to get is this little warning message that basically says that I've copied those things over, and there's some references maybe to some resources or other things that might need to be resolved. But what you'll notice is back on the main page, what it did is it just removed all those things, and it healed the process and inserted this new process step, which is kind of the higher level process step, and already created a link down to the page 2 where it did everything. So I'm going to do the control click here as it shows. See if that works. There we go, and it takes me right to page 2 where it has added and moved all those processes for you, the process steps. So as you can see, it made it really nice. Now I can move this back over here. It's a little bit closer in the process, right? And makes it really nice. So again, this capability is in Visio Premium. It allows you to simplify and organize your process flow, your models, into something that might be a little bit more manageable and easier to see. Now, I also mentioned about the data visualization and data graphics. So I have a little example here where I want to show this. This is just a simple little manufacturing cell where we have a crate of blank or raw material that comes into a receiving area. And from there, then, we unload the blanks, and they will be fed into a lathe where they're machined into a cog or a type of gear. They go on to a degrease process, then they're inspected. And at inspection, then we have a decision to make. Did it pass the inspection or did it not pass it? So just for simplicity, we send it to scrap. If it doesn't pass, of course, you could send it through a rework process if you want to. We then attach a bearing if it does pass, and we send it on to shipping. Okay, but I want to show you what the simulation can do for you here. So first of all, I'm just going to run the simulation and show you results. Okay. Again, the little guy he's turning green, showing that he's in use. I'm going to turn off the animation so we can get right to the end, and click yes to view the simulation. Now, traditionally, what we do is we have a statistics viewer that comes up where it will show you some of the things that occurred, some of the statistics, some of the cycle times, things like that. And this is where we normally can analyze what's happened in that particular snapshot of running this simulation. So things like, for the cog, the finished part, what percentage of the time, was I waiting? I was there, but I was waiting, for example, for a resource to come over and start the process. What actual amount of time, percentage of the time, was I actually in process or value-added, processing time? And blocked means that I was finished at my particular process step and I needed to move on. I can see things like the total number of exits, the average time in system, what my average cost was per part. I can see things about the resource, the percent in use. I was almost 91% in use, and some other things too. So you can see that you can look at some of the things that are happening in the system, and you can do some analysis and say, okay, what do I want to change next? Well, with Visio and the data graphics capability that you get in Visio Professional, and premium, you can kind of do some of the analysis right in Visio. So what I'm going to do is I'm going to select these shapes, and I'm going to go to my Data tab here, and I'm going to add some data graphics. Okay, I'm going to my Activities, and then I'm going to do the same thing for my resource here. And what I've set up is these data graphics show the utilization, okay, of those particular activities. It also shows the capacity and how many things can be processed in parallel. Most of them are 1, like at Degrease we have 2. And then for this resource, I'm also showing the utilization of this resource, which these are statistics that we saw in the output viewer, but now I'm bringing them right back here into the diagram and viewing them at the same time. Now, for any simulation model, you got to have some purpose. It's great to see what's happening, but you need to have an objective. So for this particular process, our objective is going to be, for this particular entity, we're going to look at increasing our throughput and reducing our cost per part. Excuse me. So now when I make changes, I'm going to run the simulation, and then we're going to evaluate how those data graphics, how those statistics change there. So when I look at the process, I can see, okay, well, now these data graphics are showing when I've got a utilization between 80 and 100%, they show up red. Between 80 down to 50, they're yellow, and from 50 and below, it's showing that green, that I might have, obviously some utilization. I have some capacity here that I can take advantage of. Now, I look at my degrease station, I see that I'm only about 72% utilized. So I look at the upstream process and say, okay, what's going on here? Well, when I kind of analyze it, I can say, well, degrease, actually that process can't start until I have 2 cogs there. So I only have 1 lathe feeding it. So if I'm only doing one part at a time, then that's not going to, really, my utilization could be down a little bit there. So what I'm going to do is I'm going to change the utilization of, actually I'm going to increase and say I want to try 2 lathes. So if I have 2 lathes in parallel here, then they can both be feeding the degrease process or the machine there. So I'm going to put 2, and then I'm going to run my simulation and see what we have here. Oh, I forgot to do something though. Hold on. Let me go back. What I need to do is to take advantage of this, I want to, rather than, now I could look at the results in the output viewer, but I want to link this to some Visio external data. And so I want to click there. I could do both if I want to, but we're just going to focus on the data graphics. So select that, run my simulation, and what it's going to do, of course, it's going to start simulating. Now, these are not dynamic. It's just showing what the previous values were. Okay, so it's not dynamically updating. But if I turn off the animation and get to the end, then when I click yes to see the simulation results, it's outputting those results to an Excel file, which then is linked to the external data linking capability in Visio, and then automatically linked to the shapes. Okay. Now, what happened is you can see the utilization didn't really change too much. I'm still about 98%. My utilization here is still about 72. You see some slight differences, but not much. If I look at my throughput, it's 48, 49 is what we had before, but my cost per part went up. So obviously that didn't do too much. It just added more cost. And so if I analyze the process a little bit, I can say, okay, well, if I look at lathe, I added another lathe, but really a worker needs to be at the lathe in order to actually kick it off and have it working. So I only have 1 worker, so I need to actually add a second worker. So I'll go in here, change to 2 units of the resource, and then let's simulate again and see what that will do. Again, I'll just turn off the animation to get to the results. And when I get here, turn off that, I can see that there's been a change now. My utilization went up from 72 to almost 98% there, just above 98%. My utilization at Inspect went up 60%. But my resources went down 80%. Now that may be okay. I'm not really modeling any break time or unavailability. So let's see what happened to our throughput here. If you can see that, we went up to 86%. Not quite doubled, but we increased quite a bit. And we actually reduced our cost per part down to under $12. So obviously that was a good impact, good change of what we made there. Now, that's nice. I mean, we've been able to do this, and notice how we've just been able to stay in Visio, and we haven't necessarily had to go in and look at some charts and graphs. We've been able to see and visualize what could happen if we make those changes, the results of those changes. Now, basically what we've been doing is a scenario analysis, kind of a what-if analysis, and we've been doing it one kind of scenario at a time and viewing the results. But Process Simulator has the ability to show all of those things at one time and compare them even in right with your data graphics. So basically what I did was I ran a simulation where my current state was where I had, well, actually, hold on. I didn't have 2 units and 2 capacity. I'm going to go back and change those here. Hold on. For my current state. Okay, but basically what I was doing was, let me get my as-is back to where I want it, to 1 here. But basically what I did was I had my current state, which was 1 worker and 1 lathe. I then increased it to 2 lathes. I then tried 2 workers along with the 2 lathes to see what that improved, and it gave us some good results. Now, if we look at our process here, maybe we could try a 4th scenario or a 3rd scenario from our baseline or our current state. And let's try adding another worker. Perhaps that'll increase our utilization around the inspection station. Right? If we add another worker, maybe that'll do it. So let's try it. Now, I'm going to run all of these scenarios together. Okay? I'm going to turn it off so we can quickly get through all 4 scenarios. What's going to happen is it's going to collect all the statistics, put it out to the Excel file, and then push it into the data graphics. So that then we'll be able to see all 4 scenarios and how they compare. And as you can see, here's my current state, 2 lathes, 2 workers, and 3 workers. If we look at the 3rd worker, which was our next scenario that we tried, it didn't really make a change here. In fact, what it did is it actually reduced our utilization to about 50%, which isn't that great for our workers. And for our objective here, it stayed about the same. It really didn't increase our throughput or change our cost per part. So that really didn't have an effect. Now, as you can see, so I'd probably remove that scenario. But as you can see, I can play around with the different things and actually compare the different scenarios and the results through the data graphics all within Visio without even having to go to our output statistics. All right, Steve, take it away.
Thank you, Kevin. Appreciate that very much. So we'll head into the tail end here and then get to questions if you guys have any. We're going to just briefly look at a couple more case studies, just some real highlights. One is an Air Force manning agency project, and I'm sure you guys can appreciate we really aren't allowed to share very much of this at all, but just wanted to at least indicate the types of things that they're doing with Visio and Process Simulator. Look at a quick Army repair depot example, and then Dave will give us a little bit more detail on one of his United Space Alliance projects that he conducted. So, Air Force Manning Agency, or AFMA, they're responsible for resource studies and analysis to look at human resource requirements across the entire Air Force. And they needed a capability or an ability to compare and contrast multiple data elements quickly and efficiently, and they needed to be able to respond to what-if queries from their senior leadership really at any time. So one particular case is that they had a very sort of time-sensitive study of a work center that they conducted, and it resulted using Visio and a simulation model, a process simulator model. They got immediate approval of quite a few additional manpower resources, as well as approval of some additional initiatives based off of this initial study. And they've since gone back, and one thing has kind of led to another continually with this once they started. After the first study, an additional 14 analysis of actions have been conducted to look at the impact on some of the changes that they're making to the work center, from a human resources standpoint. For every one of these, they were very time sensitive, so they were able to quickly go back to the model, make the changes that they needed to make to the model, and then rerun it and get the information and the answers that they were being asked for. And the very last one of these that they did actually changed the mission of one of the work centers from a purely centralized function to a centralized with several additional operating locations. So they're just doing a lot with human resource and those types of evaluations. Again, I apologize for not really being able to get into much more detail, but lots of use for these tools in the resource and human resource area. And this is a quote that they basically gave back to us after some working with them. Their feeling is that this software suite, the Visio and the process simulator together, it simplified their data capture, analysis, and decision making. So we appreciate being able to work with the Air Force. Give you a little bit more detail on an Army depot, Army Repair Depot project that was done. Their situation was this particular facility did refurbishing and resetting of equipment. This one model had to do with a water purification unit, and they were expecting their demand to increase based on all of the activity that's been going on. So they were trying to sort of stay ahead of the curve and see, if they could handle their expected increase in demand. So their current situation, their current state, they were able to produce or reset 73 of this particular type of unit per year. They called it a 3K unit. And they were working basically with 4 days a week, 10 hours a day was the schedule. So they built a pretty detailed Visio map of the process and then converted it into a process simulator model to be able to look at their baseline and kind of validate that the model runs the way their system was running. Then their objectives were to determine their maximum throughput with current staffing, so what could they get up to with the current personnel, and then once they reached whatever that max was in the model, what were their primary and secondary bottlenecks. So if they did have to go beyond that, what would they have to do? So what they found was that with the current state, this pretty much just validated the this is a throughput and cycle time chart. So the red line that's sort of going up from the bottom left to the top right that's just showing the throughput, the accumulation of the number of units they were refurbishing. So by the end of the year, this would have been 73 units up here. The blue line is their cycle time for producing or for doing the refurbishing. And, there's some variation of what you would expect. That's one of the benefits to simulation. But overall, the cycle time is pretty consistent. So, this reflected what they were currently doing. So when they went to go try to bump up their the model to see what their capacity could be, they were only able to get another 2 units a year through before they started noticing their cycle time was becoming much more variable and sort of increased at the end. So, it was slowing down. So somewhere there's a bottleneck in the system, and they couldn't get beyond the 75 units a year, really, with the current situation. So that was their one objective. The next, they wanted to know, well, what were the bottlenecks, or what would they have to do if they needed to get beyond the capacity? So they wound up finding that through some of our labor utilization and resource utilization charts that there were some labor issues, some staffing issues. This is just really a section of one of the charts, but the green indicates a resource that's utilized, and blue indicates if there's idle time. So you can see this first bottleneck is their functional test resources. They were fully utilized, so that was the area they'd have to add some resources to if they were going to get beyond the 75 units a year. And then secondly was the mechanics. So there were maxing out their mechanics as well. So this sort of satisfied the second objective, which was, okay, if we needed to increase our capacity, what would we have to do? And this gives them some very specific answers to that. And let me turn it back over to Dave now to go through a little bit of United Space Alliance example that he conducted.
Okay, thanks, Steve. I'll just quickly go through this. This is dealing with flight crew equipment. Flight crew equipment is anything that the astronauts use in flight or in flight training on the ground. Sometimes an item breaks or needs to be modified. And so a good example would be a tool that perhaps jams up during a space shuttle flight. So we would have to document the damage and get it repaired through the use of our discrepancy report process. So this is a paper process, and in fact, we shoved large stacks of paper around our facilities through various engineers and quality folks, technicians, and others. Our main problems were long cycle times, of course, delays that come with that, and sometimes we would even lose the reports. So we built a model, and we actually had used 4 separate Visio process maps. We had the model built and running in one day using Process Simulator. But we had no real initial true data, so we used some triangular distributions at first throughout until we could gather some real data. It took us about a month to do that. There's a picture of one of the process maps. There were 4 of them, which we, again, had in Visio. We integrated them, used Process Simulator like Kevin demonstrated, and we had a simulation model. After we populated it with the real data, we created 9 scenarios, and we found that several predicted pretty good results. So just to wrap up and talk about the results a little bit of this project, you can see that basically we gave management the results and we described all the 9 scenarios. And we said to them, if you do these things, then here are the results you're going to get. So management likes that when you give them choices. So the best 2 scenarios predicted 34 to 39% reduction in cycle time. That was the big problem we were trying to highlight. We also identified for management a real bottleneck in the process that at that point they did not realize was a stopping point, and it was very critical. We also helped them justify moving to an electronic reporting system. Again, all this was through the use of simulation modeling using Visio and Process Simulator. So those tools gave us another very successful project. Steve?
Thanks, Dave. Appreciate that. And so coming into the home stretch here, just sort of to reiterate and try to tie together, the value of using, Process Simulator and Visio with, any of these types of methodologies is really it gives you the ability to now leverage a technology with the methodology. So it's complementary. It's not, we're not trying to replace, anything. It's a way to help you accelerate your results. So with the idea of being able to leverage the technology with the methodologies, what our customers are finding, is that quite often there'll be a quicker adoption of the, either the particular change that's being looked at or, the initiative as a whole, because you're able to kind of get to some results, faster. You can visualize, you can see things. So we're finding some folks are having a quicker adoption. More often than not, you're getting the change right the first time because you're really able to test it. So there's no reason once you're testing it and you implement it, if you've done a decent job with the modeling, that when you implement it, it should work. And so customers are finding that. And then those 2 things kind of lead to more sustainable initiatives. If you've got quick adoption, you're getting things right, people get on board. They're whether it's the managers, people looking for the information, or the folks who are doing the work that have to kind of buy into the changes you want to make. So, there's an advantage there to using the technology to help, get folks on board and have more sustainable initiatives. Really reduces the risk. We've talked about that, risk in all sorts of things. Risk in implementing the wrong, change, risk in the failure of your initiative. So there's a lot of value in using the virtual kind of world to reduce your risk. And, improved collaboration and communication, which is a big strength of what the Visio and then the SharePoint does. It's a way to help look at, get a whole bunch of people together and look at possible answers together. So that's one of the real big benefits of this tool set. And again, it all really, the objective is to help you guys make better decisions, faster decisions, and make them now. On behalf of ProModel and Microsoft, thank you guys very, very much. We appreciate your time today, and hope we were able to at least shed a little bit of light on using these types of technologies for your process improvement applications. So thank you very much, everybody. Have a great weekend.